As you see, there's a booming cycle of intelligent mobile phone and the tablet PCs. This kind of mobile internet devices has truly changed our world and made the way we acted. Massive huge amount of data in our world has been exploding. The increasing volume and detail of information from the beginning PC generation to the cloud era is deeply captured by enterprises, and the rise of multimedia, social media, and the Internet of Things will fuel exponential growth in data for the foreseeable future. So how could we get through and digest these matters? Industrial structure is altering. It does require highly integrated technology of the cloud era. Let's talk about the storage capacity as you see in the comparison chart. And there are some big differences between hard disk and SSD. Hard disk uses spinning platters of magnetic drive for its read-write head operation. Unlike hard disk, SSD doesn't have moving parts. The reliability is more stable, but to be reality to say, SSD has some problems either. The random read-write, the limited capacity, and the security problems couldn't make the both ends meet. There are two interfaces between SSD, one is SATA and the other is PCIe. As you see in the chart, SATA was the mainstream value in the past year days. However, SSD's bandwidth and the top high computing are much more attractive than SATA. Eventually, SSD will replace SATA as the high computing performance of PCIe interface within standard storage mechanism. Speaking of giant speed solutions, the SATA Express comes up with new specification that enables the coexistence of SATA and PCIe interfaces. There is no need for driver installment. It's a major innovation as it increases the bandwidth and covers the way for integration of storage devices swifter and efficient to PCIe interface. SSD technology has become mature and widespread according to its non-volatile feature and high performances. The mainstream server interface of SSD includes SATA, SAS, and PCIe. There are large bandwidth and transfer rates for PCIe interface. So, in order to enhance the needs, NVIDIA Express addressed a scalable host controller interface designed for enterprise and client systems that use for PCI Express SSDs. And for the I/O bottleneck, nowadays seems like a big threat for us. It's used to separate into two parts of CPU, what's so-called North Bridge, and the South. And up to date, we put it into one total section called CPU. CPU does a lot of commands to hard disk, and it truly spends a lot of time to do so many orders. Furthermore, many enterprise servers eager to keep the top performance, so they use large die stack DRAM software caches to break the memory bandwidth wall. But it takes CPU's high power consumption and wastes a lot of workloads from the motherboard. The core competence is truly bad. And compared to SSD, the random read-write and the security of huge data are still the biggest unsolved challenging problems nowadays. So, should we redefine hard disk for discussion? We prefer to take the layer 2 or 3 into consideration to store our data, because hard disk has large capacity and great security. Last but not least, DRAM continues to provide high performance with random read-write stabilities. So we prefer to put it into the layer 1 for temporary access media. Under the structure of flash SSD, in order to solve I/O bottleneck issues, there are two interfaces called entry-level SATA and hybrid-level PCI interface. Due to the bandwidth and data transfer rate makes the SATA I/O bottleneck and buffering delays. Owing to speeding up cache of DRAM, it does accelerate the speeding, but as to gathering the piecemeal data, it gets retard action. And NAND flash has the reliable lifespan limits and is not suitable for the layer 1 main storage and fast cache function. Although it has DRAM support for buffering, it still cannot guarantee the data loss without a battery backup alert. And talk about our company. O1 does great support on professional research and dedicated in the IC design innovation. We value our customers and share the experiences with win-win cooperation. Below is our product line, and Cloud Disk Drive 101 RAMDisk is our unrivaled shooting star. Check out our newly development of Cloud Disk Drive 101 RAMDisk. The data go through via the PCIe slot, and you can see that in the middle of the board, our exclusive controller transmits the huge data to DRAM that store the frequently accessed memories. As for the power suddenly shut down, our patented controller will trace back the info and move out the backup data from the microSD cards to DRAM simultaneously. As for the bottleneck delays, we take 50,000 RPMs from hard disk for example. It has 2 milliseconds. SSD got 47 microseconds. And our RAMDisk 101 appears the splendid performance in 60.5 milliseconds. Our marvelous response time is 121 times faster than hard disk. Use our one piece of RAMDisk and you will get 70 pieces of hard disk IOPS high computing performances. For the competitive spec comparison, as you see in the chart, we use the same interface of PCIe Gen 1x4, more stable DDR3, and the best of breed random read-write IOPS, plus the crucial point of low latency. Speaking of the capacity, everyone always thinks that the larger, the better, but actually in the layer 1 volume of hard disk does not really need such a great capacity. Owning a 60 GB or 32 GB will solve the thousands of millions of piecemeal data. If you want to put 320 GB flash SSD into the layer 1 volume, the capacity of the huge data you used only for a few tens of gigabytes and could even store the giant clusters. By the way, if you're really allergic and worried about the capacity problem, I could make a persuasive excuse for you. We suppose that we have the same situation of the same capacity and assume that the layer 2 hard disk requires 1 to 2 500 GB capacity plus the layer 1 320 GB. The total cost compared to our 101 RAMDisk needs 2 pieces of 500 GB capacity, the same volume, but my 101 RAMDisk got low cost, low latency, and superior high performances. However, the larger volume but dangerous data loads, you still have to store the data to the layer 2 hard disk for long-lasting mechanism. So think about that. Which one is better for you? Speaking of the storage layer architecture, we would love to recommend you to use our 101 RAMDisk to replace SSD. By means of DRAM as the temporary file for accessing the frequently data, dealing with its high computing performance and outstanding stable IOPS. Unlike flash SSD, owning a DRAM for buffering cache, but still cannot take the great precautions on battery functions. Some large-scale industry software systems like Photoshop, Illustrator, WinRAR, and File Transfer, they all have the problem to do a lot of data sets, databases, and requires a temporary space where speed could be a crucial point when the clock is ticking. But using a large RAMDisk is not only the smart thing to do, but the most efficient way to handle a large amount of data with the fastest possible speed. To be honest to say, what I'm talking about RAMDisk is about the real RAMDisk, like using pure DRAM at pure RAM, which is capable of speeds that's mounted directly on the motherboard of a computer of system RAM. Is not RAM used on PCI cards. About the application study cases, as you see, our 101 RAMDisk could apply some booking system solution, high-speed computer center solution, SAP system solution, storage system, virtual machine system, and the data center apps. As for the 101 Plus, it can also support micro Windows, Linux, Unix, and Hyper-V OS systems. And with our 6-pix RAMDisk, you will have 2,500,000 IOPS. With the capacity of 512 bytes, we could reach the computing performance almost nearly 500,000 IOPS and plus an always power-on battery solution to keep the retention data be restored. Our patented controller owns the I/O low latency, low power consumption, and indeed enhance the great performance capabilities. Last but not least, if you have any interest about us, please don't hesitate to leave a message and give us a call while needed. Thank you so much.